All right, picking up on number 29. These are your linear inequalities. Right, so remember, anytime you do linear inequalities, right, that requires shading, right? So you have infinite solutions that exist either above or below the line. All right, so on all of these, I'm going to convert all of these into slope-intercept form. And the reason why I want to do that is because, remember when you solve inequalities, I'm just going to do a little refresher up here in the corner. If I have like negative 2y is less than or equal to 6, we solved these types of equations back in unit 1. So you have to remember, if I want to solve for y, I have to divide by negative 2. And remember, when you divide by a negative, that means the inequality symbol has to flip to keep the truth value the same. And so we need to make sure that we remember that. I'm going to put a little flip, right? When you divide by a negative to solve for y, the inequality symbol has to flip. Okay, now I'm reviewing that because on all these equations, only the first one is solved for y, right? It's in y equals mx plus b form. None of the other ones are solved for y. And we want to solve for y because if we need to divide by a negative anywhere while we're solving for y, that inequality symbol is going to have to flip, right? And so we need to make sure we see when that happens, okay? So I'm going to convert all of these to y equals mx plus b form if necessary. Now, this one, the first one obviously is already in y equals mx plus b form. I'm going to put a little reminder here. I'm going to put y equals mx plus b form on all of these. There we go. Okay, so this one, obviously our slope is 2, right? So our slope is 2 over 1, and then positive 1 is our y-intercept. All right, so we can go ahead and graph that as is. So positive 1 is our y-intercept, and then up 2 over 1, up 2 over 1, up 2 over 1. Or we can go down and left, get a nice straight line. Now, before we connect the dots, we need to go look at this symbol right here, right? It says y is everything greater than the line. Notice it doesn't have an equal to bar, which means that our line needs to be dashed. I don't want a solid line because that would imply that we are using the points on the line as solutions as well, and that cannot happen here, okay, because there's no equal to bar. Okay, so I'm going to put a little reminder here. This is a dashed line or a dotted line. All right, and then you have to figure out if you are shading above or below, and that also has to do with the symbol, right? That is, I keep pointing to it, right? So this means all my y's are greater than. Just kind of writing some notes here. Greater than, which means we are going to be shading above the line. Now, some people might be thinking, well, which one is above the line? Well, remember, right now, this is our y-intercept. And we're saying all the y's are greater than. So we want all the y values that are from 1 up. And those are all going to exist on this side of the line, right? Or above the line. So you can shade it fully with your pencil or just put some lines as long as I can tell which side is the shaded solution region, right? And I'm even going to write that in here. Solution region. Actually, sorry, that might interfere with what I'm trying to write here. Let's just write it over here. Solution region. So all the solutions to this inequality are in that shaded region. Not on the line, right? Because I can't use any of the points that are actually on the line because it's a dashed line. All my solutions have to be in the shaded region. So down here, when it asks for solutions, I'm just going to pick some random point. Let's say this guy right here. Right? That is the point negative 3, 2. I know he's a solution because he's in the solution region, right? And then I can go pick some other random point that's not a solution. Let's say, I'm just picking randomly, let's say here. What is that? 1, 2, 3, 4, negative 5, 2, negative 5. Okay. So obviously there's infinite possibilities that you can put in the solution blank and the non-solution blank, right? So just making sure you're picking one. All right, next problem. This one's obviously written in standard form, but I'm going to put it in y equals mx plus b form. So that's always the same two steps, right? We need to get this positive 4x term to the other side, right? So we are going to subtract 4x from both sides. All right, and that is going to give us negative 3y is less than or equal to, I'm going to put that negative 4x term in first and then kick that positive 12 out to the side so it can have that mx plus b action going on. And then, of course, we still need to get the y by itself, so we have to divide every term by negative 3. And then little bells should be going off because I just divided everything by a negative, which means my inequality symbol needs to flip. And then, of course, a negative divided by a negative is going to give me a positive 4/3 x. And then a positive divided by a negative 3 there is going to give me minus 4. Okay, so this is our y equals mx b form. And we noticed that we had to flip. I'm going to kind of make sure. All right, flip because we divided by a negative. And that was so important because we want to make sure we're shading the right side, right? If we graphed it in standard form, then we wouldn't have known whether to shade above or below the line. Okay, so let's graph this one. Our y-intercept is negative 4. Our slope is positive 4/3, so we're going to go up 4, right 3. Up 4, right 3. I don't think I can get any more in there. All right, and then the next question is, should it be a solid or a dotted line? Right, so because this is our symbol, right, because it can equal the line, it's got the equal to bar, right, that means it's a solid line. Right, so we're actually going to make it a solid line here. All right, and then the next thing we need to know is which side to shade, right? So that is a greater than, so we're going to shade above the line. Once again, above the line, here's my current y value, my y-intercept. We want all the y values that are greater than that. So we should be shading the side that contains all of those greater y values. All right, so a solution would be any point in the solution region. I'm just going to pick, let's say this guy, 0, 3. All right, and then a non-solution would be, I don't know, this guy right here. What is that? 1, 2, 3, 4, 5, 6. Obviously, you can have totally different answers here than me. Just pick any point that's not in the shaded region. All right, and lastly, this guy. I definitely want to put him in y equals mx plus b form. This is not even point slope form. It kind of looks like it, but it's not because it's got this weird 2x thing going on right here. So we are going to solve for y. So step number 1, of course, would be to distribute that 2 to get rid of the parentheses. So 2x plus 2. All right, I'm going to bring everything else down. All right, we need to get that y by itself. So we need to subtract this 2x term to the other side. And x's can combine with other x's. So we end up, we don't need to flip the sign because we're not dividing by a negative anywhere. 2x minus 2x actually gives me 0. So this is also going to cancel out. So I'm just going to get the equation y is less than 2. All right, well, we know how to graph lines like y equals 2, right? It's just a horizontal line crossing it 2. It has no x, so it can't cross the x-axis, right? But we also know that this little guy doesn't have an equal to bar, so this should be a dashed line. Right, so here we go. It's going to be at 2. So a horizontal line because it's got a slope of 0. And it's also a less than symbol. Oh, let me change colors here. I'll go with lavender here. Here we go. All right, so this is a less than symbol, so that is telling us to shade below the line. So my solution region is any point that exists below that dashed line. So you can pick any point you want, right? So if I pick this point right there, 1, -1, right? And a non-solution would be anything that's above the line, or I could also pick, just make sure we understand, I can pick any point on the dashed line like 2, 2, and that would not be a solution because it's a dashed line, right? And so anything on the dashed line would not be a solution. All right, so there's our review on linear inequalities. All right, let's go talk about writing equations in slope-intercept form. All right, here we go. The graphs should be nice and easy, right? All you need to do is find the slope and the y-intercept. So, because it does say slope-intercept form, right? So y equals mx plus b. All right, so let's see. Clearly our y-intercept on this graph is 0, 2. And our slope, remember, is rise over run. So it looks like we're going down 2, which is -2. And then right 3, which is a +3. So our slope is -2/3, which makes sense because this is a decreasing line. So it should be a negative slope. And then you just need to throw those two numbers into your y equals mx plus b. So y equals m, which is -2/3, x plus the b, which is +2. Easy peasy, no work involved. You get all the information right there in your graph. All right, now this one is kind of tricky, right? Because you'll notice that we don't know where it's going to cross the y-axis because it will cross somewhere, right? But it's just like way up here. Now, could you figure that out by working backwards in the graph and all that? Yes. But the point of this question is that you don't know the y-intercept, which means you shouldn't be starting in y equals mx plus b form. We have points and we can find the slope, so we should be starting in point-slope form. If you don't know the y-intercept, then you should be starting in point-slope form, right? So let's pick a point. Let me write point-slope form down. Y minus y1. Again, this is on your formula chart. You don't have to have these memorized. All right, I'm just going to pick this point just because I like it. It's the point 2, 4. You can pick this point if you want to. It wouldn't matter. And let's see, what's our slope? Let me make a little line here. It's definitely negative because we're going down, what? 1, 2, 3, 4, 5, down 5. So -5. And then over to the right one. So -5 over 1, which is just -5. You can keep it over 1 if you want to, but I'm not going to. All right, awesome. So now that we have a point and a slope, right, we're going to take these values and plug them in for the y1, the m, and the x1. So here we go. Y minus the y1, which is 4, equals -5 times x minus the x coordinate, which is 2. So yay, so we used the graph to get it in point-slope form. Now we need to convert it into slope-intercept form, which is super easy. Step number 1, distribute, right? Our goal is to get it in y equals mx plus b. So y minus 4 equals -5x. And then -5 times -2 is +10. Notice the mx plus b action starting, right? The last thing we have to do though is to get the y all by itself by adding the 4 over to the constants on the other side. So that is going to give us y equals -5x plus 14. And so this line would cross the y-axis way up there at +14, right? But we used point-slope form to get us there. All right, next up, kind of the same thing. I have 2 points. I have no graph, so I'm going to have to start from scratch. If all I have is 2 points, then I need to start with my slope formula because I need the slope. I can't really do much without slope, so here we go, slope formula. So 5 minus 3 is the difference in my y's, and then 0 minus 2. So So 5 minus 3 is 2. 0 minus 2 is negative 2. So my slope is negative 1. Now, here's the really awesome thing. If you want to do point slope form from here, like we just did up here on number 33, you totally can. However, the really awesome thing, if you happen to catch it, is this guy right here. He's the y-intercept. Y-intercept. Yay, happy face. If one of your points is the y-intercept, well then I can go ahead and write it in slope-intercept form right now. Y equals mx plus b. My slope is negative 1 x, and my y-intercept is clearly 5 because that point is a y-intercept since the x value is 0. If you don't catch it, it's okay. You can do point slope form. Pick one of those points, throw it into point slope form, and then solve and put it into y equals mx plus b, and you're going to get the exact same answer. But if you catch it at the beginning, it's all the quicker. All right, this one right here. Oh my gosh, so many of us are still missing this on our quizzes and stuff, right? Please remember, this is f of x equals y. This is function notation, right? So please, when you see this, please do not freak out and just make up random stuff, right? It's very easy. F of 4 equals 2. All that's telling you is that the x value is 4 and the y value is 2. So it's giving you the point. Sorry, I'm trying to, there we go. 4, comma, I'm trying to color code it here. 4, comma, 2. Right, that's all that means. It's just a fancy way of writing 4, comma 2. That is it, right? Same thing over here, right? The 7 is the x value. The 2 is the y value, right? They're telling you that when you put in a 7, you get out a 2. You put in a 7, you get out 2. So you're right back to this question right here. It's the exact same thing. They're just writing the points in function notation instead of just flat out giving you the points. But you have to recognize that that's what that means. Okay? So clearly we need to find slope, right? So we're going to do our slope formula. Anytime you have 2 points, you need to use slope formula. All right, so y2 minus y1. So 2 minus 2 over 7 minus 4, which it doesn't really matter what we get in that denominator because 0 divided by anything is 0. All right, so there's a couple different ways you can go about this problem. I'm kind of going to do this one the long way just so it makes sense, hopefully. So now that I have a slope, I'm going to pick a point. It doesn't matter which one. I'm just going to pick 4, 2. And I'm going to do point slope form because clearly neither one of these are the y-intercept. So I need to do point slope form. So here we go. So y minus 2 equals m, which is 0, x minus 4. Now look at this. 0 times x minus 4. Well, what's 0 times anything? 0. So all that mess over there is just 0, right? 0 times anything gives me 0. And so then I'm going to add 2 to both sides to get the y by itself. And that is my equation of the line, y equals 2, which I'm hoping makes perfect sense. You technically didn't even have to do any of this work right here because as soon as I know the slope is 0, that means it's a horizontal line. And all horizontal lines are of the form y equals and then whatever number. And it should be very obvious from the points that the y value is always 2, right? Because your points are 4, 2 and 7, 2. So of course the equation is y equals 2 because my y value is always 2, okay? So you could have just hopped to the y equals 2 after you found out the slope was 0 if you wanted to. All right, moving right along, convert each into standard form. All right, so remember standard form means all of our x's and y's are on the same side and the constant is on the right, and you can have no fractions or decimals, and the first term has to be positive. You guys were really good at this in class. So, so clearly on this first one, this is in y equals mx plus b form, but I want it in standard form. So I want to move all my x's and y's to the left. Well, if I want to move a positive 4x to the left, that means I have to subtract it. right? So that's going to give me negative 4x. That y is positive, so I need to make sure to put a plus sign in front of him now because he's in the middle of the problem. And then that is a negative 2. Please make sure you bring the negative down with the 2, okay? All right, and then we're pretty much done, right? We've got all the x's and y's to the left and the constant to the right. The only problem is, we have a negative x term, and in standard form, you cannot have that. So we are going to fix that by dividing every single term, or multiplying, by negative 1. Because I don't really care about the 4. I don't want to divide by negative 4 to get the x by itself. The 4 is fine. I just need him to be positive, right? So we're going to divide everybody by a negative 1, which essentially just changes everybody's signs, right? The 4x becomes positive, the positive y becomes negative, and the negative 2 becomes positive 2. And there is our standard form equation. All right, here we go. This next one, this is in point slope form. We need to basically get it into slope-intercept so we can then convert to standard form, right? So this one's going to take a few steps. Step number 1, of course, is we need to get rid of those parentheses. We can't work a math problem that has parentheses in it. So y plus 5 equals 1/2 times x is clearly 1/2 x, and half of negative 6 is negative 3. Again, feel free to use your calculator wherever you need to. All right, so we've got a couple of things we need to take care of here. Number 1, I'm going to kind of do it in the same order that most of y'all did it during class when we were talking about this. I'm going to go ahead and get all my constants over to the right-hand side. So we're going to subtract that 5 over, which is going to give us 1/2 x minus 8. All right. Then, if you want to go ahead and get rid of the fraction, you totally can. Guys, you can do these steps in whatever order you want, right? It really doesn't matter. I'll go ahead and get rid of the fraction, though, because I need to get rid of this divide by 2, which means we need to multiply everybody by 2. All right, and these 2's cancel, which is the whole point, right? So that's going to give us 2y equals positive 1x, and then minus 16, right? Because the 8 times 2. All right, so we got rid of the fraction. Yay, because standard form can't have fractions. We're close. We just need to get our x's to this side, right? And the only way to move a positive 1x to the other side is to subtract it. All right, so these cancel. And then, so that's going to give us negative x, or negative 1x, plus 2y equals negative 16. So it's starting to look really great, except the last thing is that darn negative 1, right? I can't have a negative starter on my x term. So just like the previous problem, we are going to divide everybody by negative 1, which essentially just switches everybody's signs. It's okay as long as you do it to everybody. So x minus 2y equals positive 16. And that is my standard form. Now remember, you don't have to do yours in the same order that I did mine, right? As long as you can get it in standard form, you can kind of do those steps in whatever order you want, okay? After you distribute, of course. All right, write an equation in standard form. Okay, these were those super long problems, right, that took us a while in class, but you guys were starting to get really good at these. So we're going to have to start all the way and go through all the steps, right, because we're going to have to do slope formula. Then we have to use point slope if none of these are y-intercepts, which those are not. And then we're going to have to turn it to slope-intercept, and then we got to take it to standard. So we're going to have to go through all the forms to get to standard. Notice all the space that we give you for this. Here we go. So slope formula, y2 minus y1, so negative 5 minus 7, 2 minus negative 1. So the double negative is going to change that into a plus sign. All right, simplify that as much as we can. We're going to get negative 12 over 3, which is negative 4. All right, so I've got my slope. I need a point now. I'm just going to pick this one. I'm going to pick 2, negative 5. It doesn't matter at all which one you pick, right? Oopsies. But now we're going to put that into, I really want, all right. I'm going to put that into point slope form. Right, so here we go. I'm going to kind of try to keep this point slope. Here we go. All right, So y minus negative 5, right? I'm using this point, remember? So that's going to change to a plus with the double negative, equals m, which we just found was negative 4, x minus 2. So there's point slope form. All right, now we need to convert that basically into slope intercept form, right? So we're going to distribute. So y plus 5 equals, we're distributing negative 4x plus 8. All right, and then I'm going to go ahead and subtract this 5 over. So we're going to get y equals negative 4x plus 3. So that is slope intercept form. That's a little cramped, but that's okay. Let me scooch that over so it's not so cramped. Give me a sec. Clean that up a little bit. Slope intercept. There we go. All right, and then now we need to get that into standard form. And of course, this one's actually pretty easy, right? Because, let me just go standard. We just need to get all of our x's and y's to the left, which means we're going to add this 4x over, right? We're going to add the 4x to this side, right? So that's going to end up giving us positive 4x plus y equals 3. And we're done, right? Because we didn't have any fractions. Our first term is positive since we added the 4x over. So yeah. All right, but just kind of being able to go through all the forms to get to standard form. All right, doesn't look too bad. Not too many steps. All right, let's do all that one more time. Here we go. Slope. 3 minus 0. Negative 3 minus negative 7. So again, double negative changes to a positive. Let's see, that's going to give me 3 over 4, and I can't simplify that, so I'm just going to leave that as 3/4. All right, now we need to pick a point. I'm just going to pick negative 3, 3. It doesn't matter which one. Remember, this is not a y-intercept. That's actually an x-intercept, so that doesn't do me any good. Okay, so here we go. Point slope form. Y minus 3 equals our slope of 3/4 x minus negative 3. And again, I'm just going to change my big double negative there. Oops. There we go. Double negative into a positive there. All right. Now we need to convert to slope intercept form. Okay, so here we go. Y minus 3 equals 3/4 x plus, now this is not going to be a friendly distribution, right? Because 3/4 times 3 is going to give us 9/4. Again, please use your calculators, right? It's easy to just type that in your calculator and hit math, enter, enter, and realize that that's 9/4. Okay. All right. I don't know about you, but I'm going to go ahead and multiply by 4 to get rid of all of these fractions, because my goal at the end of the day is standard form. So I'm going to go ahead and multiply every single term by 4, right? Because I got to get rid of these divide by 4s, right? It's just going to happen sometime, so you may as well do it now. You could have also done it on the previous step. So these 4s are going to cancel. Okay, so let's see, what are we left with? When we multiply everything by 4 over here, that's going to give us 4y minus 12. And then we're left with just the 3 up top with the x. Don't forget about the 3 and the x that are left. And then over here, we're left with plus 9. Oh, that looks so much better. All right, so I'm not actually going to go through, I'm not going to actually put this in slope-intercept form, right? I don't have to go through slope-intercept form to get to standard form, right? I'm almost there, actually, by adding the 12 over here, right? That's going to get me, what, 4y equals 3x plus 21. Okay, we're getting there. I'm going to have to come up here. Sorry, I ran out of room. Let me, sorry, I can't stand crooked lines. All right, here we go. I'm just going to pop up here. Let me write that same thing down so I don't lose anybody. Here's our last step. All right, so standard form, we need all those x's to one side. So I'm going to have to subtract the 3 x's over here. All right, and so that is going to give us negative 3x plus 4y equals 21, which is oh so close, except we can't have that negative starter on the x term. So we're going to divide everybody by -1, which essentially just switches everybody's signs. Because if you switch the first sign, you got to switch everybody's. So 3x minus 4y equals -21. And that is our final answer in standard form. Now, could you have probably done that in like one less step or two? Yes, you could have, right? But I just chose to go ahead and do it this way. I didn't go through slope-intercept form. I just went through point slope, and then I just kind of manipulated my way to standard. Okay. All right, our last few problems here, we're going to do some story problems. All right, so number 40, a zookeeper thinks there is a problem with the naked mole rat population. Okay, at the zoo. He starts keeping track of the animals in the tunnels. 7 days into his monitoring, he counts 120 mole rats. Okay, so clearly this is giving me a point, right? Please remember that time, right? When it says days, time is always x. Just because it's written first that's not why it's the x value, right? Time is always x. Okay? So that is giving us the point 7, 120. Right? So clearly, again, I know it's not asking us to do this, but I'm going to kind of sketch a little graph. Right? So this is days is my x. And then number of rats or mole rats. I don't even know what those are. Number of mole rats. Are those even real animals? I don't know. All right. Let's see. And then it says 13 days in, he counts 108. Well, that's giving us the point 13, 108. So clearly the population is decreasing, right? Because we can see as more time has gone by, there's less of them. All right, so then the problem says write an equation in slope-intercept form. Okay, so I would highly suggest writing down what that means, right? So that's y equals mx plus b, right? Excuse me. So the fact is they did not give us the slope. I did not see the words per, each, every. They didn't give us a rate of decrease, right? There's nothing in the problem that said like the number of mole rats is decreasing by 5 per day or whatever, right? And so that means we have to use our 2 points of data and we got to find the slope ourselves. So here we go. I'm just going to go over here. Again, I feel like this is like the 50th time we've done this. So I'm just going to do y2 minus y1. So 108 minus 120. And then x2 minus x1. So 13 minus 7. It has to be in that order. All right, and so let's see, what's that going to give us? 12, I'm sorry, negative 12, all right, over 6. So our slope is -2. I did not write the negative, did I? There we go. All right, so which basically translates into, on average, the mole rat population is decreasing by 2 rats per day, right? That's what -2 means. All right, so let's see. Now we need it in y equals mx plus b form. Clearly, neither one of these points is the y-intercept, and the y-intercept represents how many starting rats there are. Well, I don't know, right? And so we're going to use point slope form. I'm going to choose the 7, 120 as the point. You can pick the other one. It matters not. So here we go. Y minus y1, which is 120. Equals the m, which we just found out was -2, x minus the x1, which is the 7. And then I need to convert that into y equals mx plus b form. So we're going to distribute the -2. And then we need to add the 120 over to get the y-intercept. Right? And so that's going to give us y equals -2x plus 134. Which means on day 0, they started with 134 mole rats before they started counting their decrease. All right, then it says, so here we go. Let me just kind of graph this situation, right? So this is kind of what our graph is going to look like, right? So we started off with 134 mole rats. Can you read that? That's really tiny. Right, this is 134 mole rats on day 0, right? And then they're declining, declining, declining. And if they don't do anything, eventually they're all going to die off, right? So on the next question, it says, when will the mole rats be gone? Well, that's this day right here, right? That's when are there 0 mole rats left. So they're basically asking you for the x-intercept, right? So when they're saying, when will the mole rats be gone, right? That's how many days, right? So they're asking you for the x-intercept. And remember what x-intercept means. We've already had this conversation. What is the x when y is 0, right? That's what they're asking you to find. Well, we already have our equation, right? So we're going to go to our equation. We're going to plug a 0 in for y. And then we're going to solve for x, right? So obviously we're going to subtract the negative 134 over first to start getting the x by itself. Cross those out. That's going to give us negative 134 equals negative 2x. And then we're going to divide by negative 2. And that is going to give us x equals 67. And that would be 67 days. So if they don't do anything to intervene, right, the population is going to decrease by 2 per day. And if you start with 134, that means 67 days, there'll be 0 rats left. Okay. All right. Next one. LaShawn has completed 5 miles of a marathon and is holding a pace of 7 miles an hour. Oh my goodness. They're using the word "and" here, but we could also say per, right? So as soon as I read that 7 miles an hour or 7 miles per hour or each hour or every hour, that is our slope. And you have to recognize that, right? He's already 5 miles in, though, at this point, right? He's already completed 5 miles. So that's like his starting distance of where he's already going. So this is our y-intercept. Which means our equation is y equals, our slope is 7, so 7x plus 5. All right, so of course the slope is 7 or 7 over 1, either way. And our y-intercept is 0, 5. All right, so it says a marathon is 26 miles, roughly, and LaShawn maintains his pace. What would be a reasonable domain and range for this situation? This was from last unit. Reasonable domain and range, right? So this is ours. We got to think about this. A table would also be a great idea here too. And this is miles. All right, so he's already completed 5 miles. So our line representing this situation is starting at 5. And he's running 7 miles an hour. Sorry, excuse me. So after 1 hour, he is 7 miles further along, right? Which means, oh, that's not a very good, my graph is not going to be very accurate. You know what? Let me try to make it a little more accurate. Let me move the 5 down a little bit. There we go. I'm going to move the 5 down here. There we go. All right, so if that's 5, after 1 more hour, he's gone 7 more miles. So now he's going to be at 12, right? So 5, 10, let's say this is 12. And then after another hour, he's gone another 7 miles. And so that would be 19. And then after another hour, He's gone another 7 miles, and that would be 26. And we're going to just say that's 26. I know it's 26.2, right? But this would represent the line, right? And we would connect it because obviously you can run for fractional hours, right? So they would be dots that were connected. So remember, reasonable domain, right? Remember what domain is, right? Domain, this is my domain, right? It can't go forever left, right? It hits a wall here and it hits a wall here. So all of our x values are between 0, right? There's 0, and 3. So we're going to write that as the x values are all between 0 and 3. Remember, these are always less thans when you have double walls. And then, of course, we can actually have 0 and 3. Those are solid dots. So that's going to be that. Right? I'm going to highlight, right, our domain. Okay, and then our range, right, is going to be the lowest y value, which is not 0, right? It's actually at 5 to 26, right? So our y's are between 5 and 26. They're solid dots, so less than or equal to's, right? And there's our range. So just make yourself a little graph, right? It's so much easier. Or you can do a table, right? Remember, we made a lot of XY tables also instead of graphs. All right, moving right along. Is this our last page? No, it is not. All right. Number 42, Timmy is competing in a hot dog eating contest. Write the equation in slope-intercept form. Okay, so again, remind yourself, right? I always, anytime it tells me what form to use, I'm always going to write the formula. All right, sketch a graph, blah, blah, blah. Okay, so obviously the first thing we need is the slope. And it's a table, so obviously our hot dogs are decreasing by 6, like that's our numerator. Every, and then our change in x, right, is by positive 2. Sorry, let me scooch this down so I don't run in there. All right, so that means our slope is negative 3. If you don't mind, I'm going to go ahead and hop down here to this question that says, what does the slope represent in this situation? Okay, well, our slope is negative 3. I'm just going to write that down. Or negative 3 over 1. Right? And we're talking about a hot dog eating contest. So he's starting with a certain number of hot dogs, and over time, obviously the number of hot dogs is going to decrease because he's eating them, right? And so the slope is the rate at which he's eating hot dogs, right? So Timmy eats 3 hot dogs per minute. Because remember, that's technically negative 3 over 1. Right, so you need to describe the negative 3 and the 1. Now, the negative is being described by the word eats. If you want to say something like the number of hot dogs is decreasing by 3 per minute and use the word decrease, you can. But eats, that word is giving us the negative connotation, right, that we're decreasing in number of hot dogs. So either one is fine. So Timmy eats 3 hot dogs per 1 minute. Or just per minute is fine. I just like to make sure I have the 3, the negative, the 3, and the 1, right? All of those should be accounted for when you're describing the slope or the rate. Okay, now we need the y-intercept. Well, unfortunately, they didn't give us the y-intercept. So you can figure it out, obviously, by working backwards in the table, because clearly if you go back another 2 minutes, you're going to hit 0. So you should be able to go back another 6 hot dogs, and you're like, oh, 40. If that doesn't make any sense to you, that's okay, right? Just do point slope form, right? I'm just going to pick a point. Let's say this first guy, and I'm just going to do point slope. So y minus 34 equals our slope of negative 3 times x minus 2. And then just convert that into slope-intercept form, right? So we distribute and then move the constant over. It's the same steps every single time. It's just kind of like a broken record, right? I'm going to go ahead and just write that equation down here. Y equals negative 3x plus 40. Okay. All right, so we want to graph this scenario. Now, I noticed on a lot of your homeworks, a lot of you guys either skipped the graphs or you might have drawn some random lines, but you didn't label the axes. And that's like the most important part, right? Please make sure you are labeling the axes every time you draw a graph, right? So this is time. If you want to put minutes, that would be great. Or you can just put minutes. You don't have to put time if you don't want to, right? And then, of course, the y-axis is number of hot dogs. If you do not label your axes, I'm going to take off major points, but they are the most important things on the graph. All right, and so clearly this y-intercept, right, is telling us the initial number of hot dogs, like how many hot dogs they started with. So they started with 40 hot dogs. I think I have enough room to count by fives. So 5, 10, 15, 20, 25, 30, 35, 40. I do. So my first point is going to be right there. Put that in blue. Right, that is my y-intercept. And then we're going down 3 hot dogs per minute. Right, so let's see. 1, 2. I'm just going to go by ones down here. 9, 10, 11, blah, blah, blah. Okay. So if I'm going down 3 hot dogs every minute, I know this isn't going to be this is not going to be awesome because I'm going by fives, but that's okay. We'll live. So I'm going to go down 3, so like 30. I'm going to go down to 37-ish in this first minute. And that's 37, right? And then it's going to be 34 after 2 minutes, which again, you can just look at the table. Right, after 4 minutes, there were 28. I'm just going to use the table info if that's cool with everybody. At 8 minutes, there were 16. And it should be a nice, perfectly straight line. Obviously, it's hard to be exact. At 11, there were 7 hot dogs left. Right, so this is kind of what our line is looking like. Okay. All right. Now, obviously, I put an arrow right here. Obviously, it's not going to be going down forever and ever and ever, right? Once we hit the x-axis, right, that line will stop, right? Because there's no such thing as negative hot dogs. So, anyway, so looking at this next question, this is where this is going to pop up. What do the x-intercept and y-intercept mean in this case? Well, let's do the y-intercept first because that's the easiest one, right? So 0, 40, right? So that, of course, means that Timmy started with 40 hot dogs. Timmy started with 40 hot dogs. That's the initial number of hot dogs. If you want to be super specific and say at 0 minutes, Timmy had 40 hot dogs, that's the same thing as saying that he started with 40 hot dogs. So I'll take it either way. And then, of course, the x-intercept, and now here's a problem. I don't really know where that's going to hit the x-axis. I shouldn't have continued that. Right, because my graph didn't go that far, right? It would stop right here, though, right? And I'm not really sure. I'm going to erase that arrow. I'm not really sure what that number is, but how could we figure that out? So remember, the x-intercept is the x value when y is 0. All right, so I'm going to go off to the side over here. If y is 0, then my equation would be 0 equals negative 3x plus 40. And I can solve that equation now for x, right, by subtracting 40 on both sides. And that's going to give me negative 40 equals negative 3x. And then I'm dividing by negative 3 on both sides to get the x by itself. All right, now this is really crazy, right? Because it's going to be x equals, obviously a negative divided by negative is a positive. Now, normally I would never, ever, it would technically be 40 thirds. But that's really weird because that's 40 thirds minutes, right? So in actuality, I'm going to actually write that as 13 and a third minutes, which I never ever would tell you to write a mixed number usually. But it's 13 full minutes and then a third of a minute, which is 13 minutes and 20 seconds, because a third of a minute is 20 seconds. So I would actually be okay with any of these responses, right? So I'm going to go ahead and just put 13 and a third. If you want to leave it as 40 thirds, that is great, right? But I'm just going to write, it takes Timmy 13 minutes, 20 seconds to eat all the hot dogs. Or you could say to have 0 hot dogs left, right? If you want to throw the 0 in the mix. All right, that one's kind of crazy because it doesn't divide out to a nice, pretty whole number, but that's okay. All right, what would happen in the context of the situation if the slope decreases? Okay, so again, I like to kind of remember that currently my slope, here I'm going to do like a, oops, okay. I'm going to do like a for example, because I always like to put numbers to this. So for example, right now the slope is -3. What if it changed to something smaller? Because it says decreases. So I just think of a number smaller than -3, which would actually be -5. Okay, so because my slope is negative, instead of him eating 3 hot dogs per minute, now he'd be eating 5 hot dogs per minute, right? So if the slope decreases, it actually means his hot dog eating pace speeds up, right? His hot dog, this is weird. His hot dog eating rate would speed up or would increase. Right, that's because we're on the negative side, because the slope is negative. Okay, if the slope were positive, then that would mean his pace would slow down. Right, it's kind of a weird question. All right, and then lastly, it says, what would happen in the context of the situation if we increase the y-intercept? So again, just kind of give yourself a for example. Right now the y-intercept is 0.40. What if we increased it to like 0.50? Well, the y-intercept represents how many hot dogs he started with. So if you increase the y-intercept, then that means Timmy starts with more hot dogs. So Timmy would start with more hot dogs. All right, so again, just kind of give yourself an example, right? Decrease the number, increase the number, and just kind of think about what that means. All right, last page, here we go. All right, Damien is buying lunch. The equation that represents this situation is 20 minus 4x, where x is the number of hamburgers he purchased and y is the money he has left. Okay. Identify the value and meaning of each piece of the equation. Okay, so they're already giving you the, oops, I meant to highlight that. They are already giving you the equation in y equals mx plus b form, but please notice that they have written that backwards. Instead of y equals mx plus b, they've put the mx at the back and the b in the front. Please, please, please be aware of that, right? And so that means the 20, because it's our constant, that is our y-intercept, right? And -4 is our slope, the number in front of the x when it's in y equals mx plus b form. Okay, so be super, super careful. All right. So we're talking about, I always like to make a graph. You don't have to do this if you don't want to. All right, but I'm going to kind of draw myself a little graph really quick. So y is the money left, right? And x is what? The number of hamburgers he purchased. Number burgers. So you could always type this in your calculator, right? 20 minus 4x is telling us he started with 20 burgers, right? Sorry about that. $20, right? And he is slowly decreasing until he gets to no money left, clearly. All right, so the y-intercept is obviously 0, 20. Right, so he starts with $20. If you want to be even more specific, you can say if Damien buys 0 burgers, he will have $20, right? That's the same thing as saying that that's what he started with. All right, and our slope is clearly -4 or -4/1, which is basically telling us, right, that his money, I'm just going to write $sign if that's okay with everybody, decreases by $4 every one burger, or per one burger. I really, really want the word, the phrase decreases by or something. You have to describe the negative. Please do not just say that the hamburgers cost $4 a piece. That is true, but you are not telling me whether the line is increasing or decreasing by just telling me that the burgers are $4 a piece, right? Maybe he is spending money, right? If the Y was spending money, then my line would be increasing at $4 a burger, right? But now we're talking about money left, so we have to make sure that we're decreasing our money by $4 per burger. Okay, super important. All right, the x-intercept. Well, you need to go figure out what that x-intercept is, right? When is he going to run out of money? So you could just do this logically. Like, obviously, if he has $20 and they're $4 a piece, how many burgers can he buy? Well, clearly that's 5 burgers, right? Because 5 times 4 is the $20, right? So we know that that's going to be 5 burgers right here. Right? If you're like, I'm not sure about that, then you can always do what we always do to find x-intercepts. We put a 0 in for y, and we solve for x, right? This is how we find x-intercepts, right? So we would subtract the 20 to the other side, and then divide by -4, and we would get x equals 5. Okay, but I think that's something that we can pretty much figure out just using just logical number sense, right? But you can totally, sorry, I'm trying to get that down here. Right, you could totally solve it algebraically if you want to by plugging a 0 in for y, right? So our x-intercept, right, is 5, 0. Again, we should always write it as a point, all right? And we're just describing that. So when he buys 5 burgers, he will have $0. If you want to say Damien will run out of money after buying 5 burgers, that is totally the same concept. So I would be fine with that as well. Oops, sorry. Explain the point 3, 8. Well, of course, 3 represents burgers and 8 represents dollars. So after buying 3 burgers, sorry, I'm starting to get really sloppy. After buying 3 burgers, he will have $8 left. Okay, again, just always being aware of what your X's and Y's stand for. All right, next one, Timmy. Of course, Timmy finds himself stranded on a boat in the ocean. The equation y equals 12 minus 4x. Okay, I'm going to highlight that again. Again, notice that the y-intercept again is written first. The constant is always the y-intercept when you're in y equals mx plus b form, and the -3 is your slope. Okay. X is the number of hours he's been floating around. Okay, again, I love to create a little graph just to give myself a visual right? So X is the number of hours he's floating around, and Y is the pounds of food he has available to feed the tiger he is sharing the boat with. Oh my gosh. Okay, I did not write these problems. Pounds of food for the tiger. All right, so clearly according to this equation, how many pounds of food are we starting with? Looks like 12, right? And so I know that when I graph this, I'm starting at 12, right? And eventually I'm going to feed the tiger every hour, and eventually I'm going to run out of food, which is definitely going to pose a problem for Timmy. All right, so our y-intercept, right, is 0, 12, right? So he starts with 12 pounds of food, or you can say at 0 hours, Timmy has 12 pounds of food. And you could say for the tiger or whatever, I don't really care. Or you could say Timmy starts with 12 pounds of food. It's the same exact thing. All right, the slope is clearly -3 or -3/1, which means the food decreases, because it's a negative slope, decreases by 3 pounds per 1 hour, or just per hour is fine. Just making sure, again, when you're describing slope, I cannot say this enough times, you must describe the negative, you must describe the 3, and you must describe the 1, right? Decreases by 3 pounds per 1 hour, right? All of that has to be in there to be a proper slope description. Or if you want to say the tiger eats 3 pounds per hour, right? The word eats could be used to describe the decrease. I would take that too. All right, the x-intercept is when he's going to run out of food. Again, I think we can figure this out just with basic number sense. If he has 12 pounds of food and the tiger is eating 3 pounds an hour, well then after 4 hours, he's going to be out of food, right? And so that is our x-intercept, right, at 4, 0, right? So at 4 hours, there's no food left. Or you could say Timmy runs out of food after 4 hours. Again, as long as both the concepts there, you're good. Explain the point 26. Okay, after 2 hours, after 2 hours, there's 6 pounds of food left. All right, 2 more to go. Jillian is running a snow cone business. The equation y equals 25x plus 40. Okay, again, I'm going to stop right there. This one's written in proper order, right? Where the 40, that's our constant, is the y-intercept, and the 25 is our slope. Represents her fee, where x is the number of hours. Okay, so again, I like a good graph. All right, so x is hours, and y is the total fee she charges. All right, so fee. Or I'm just going to, basically money. And according to this, right, she's starting at 40. All right, so we're starting at 40. And then every hour she earns $25, right? So our graph is basically doing this. This one's not going to hit the y-axis, right? All right. Let's see. The y-intercept. All right, so 0, 40, clearly, right? So at 0 hours, she charges $40. Right. All right. So basically, just to her initial charge is $40, right? Whether you buy any snow cones or not. Okay. I'm assuming it's like a snow cone truck or something like that, right? Our slope is 25 or 25 over 1. It's positive, right? Which means her total fee increases, because we've got to have something that tells me that's positive, increases by $25 per 1 hour, right? Again, I have the increases by that tells me the slope's positive. I'm representing the rate of $25 over 1 hour. Okay, everything's in there that we need. All right, the x-intercept. Now this one's tricky because on the previous problems, they were decreasing slopes. So they were all eventually going to hit the x-axis. This one is a positive slope. So it's going up forever. Will it ever hit the x-axis? I mean, if you drew the line backwards this way, is it going to hit the x-axis back here? Yes, but that doesn't make any sense, right? Because there's no such thing as negative hours, right? So when my graph starts at positive 40 on the y-axis, I can't go backwards to hit the x-intercept. So I'm just going to put NA, right? This is not relevant at all because I can't have negative time, okay? So will it cross the x-axis? Sure, if I kept the line going, but negative time has no concept here, okay? And then, of course, the last question, explain 2, 90. So at 2 hours, her total charge or her total fee is $90. Yes. All right, number 46, our last one. Lisa has $20 for lunch. Hamburgers cost $3 each and cookies cost $2 each. Write an inequality where X represents the number of hamburgers she buys and Y represents the number of cookies she buys. Identify at least 3 popular lunch combinations. All right, so this is a classic standard form. We talked about this in class, right? It's $3 each cookie. And they do tell us, hold on, we got to be really careful here. I want to make sure I'm reading ahead. Let's see. Y represents the number of cookies. So, oh, I'm so sorry. Ignore me. I did not receive. Never mind. I'm losing it, y'all. Here we go. So, it's been a long video. Let me get a good color here. There we go. So hamburgers cost $3 each. And they tell me right here, X represents the number of hamburgers, right? So hamburgers are $3 each. So that tells me that 3X is going to be in my equation, right? Then they tell me that cookies are $2 each, right? And right here, it tells me that Y represents the number of cookies, right? So that's going to give me a plus and then 2Y, right? $3 per hamburger plus $2 per cookie. She wants to spend, she only has $20. Please notice right here, it says write an inequality that represents how many hamburgers and cookies she could buy with her $20, right? So obviously if this is the amount of money she's spending, 3X plus 2Y, it must be less than or equal to $20. Okay? All right. So we did this in class, if you remember, with the shirts and dresses situation, right? So we basically want to kind of run through the gamut and see what kind of combinations, of cookies and hamburgers that she can buy. Okay, before we get to that, let's answer this question really quick. Can Lisa buy 6 cookies and 3 hamburgers? Well, I don't know. Let's see. Remember, cookies is Y and hamburgers is the X. So be really careful. So if she could buy 6 cookies and 3 hamburgers, it would have to be a solution to the inequality, meaning if I plugged those numbers in, it would have to be true. So here we go. 3 hamburgers. So let's see. 3 times 3 plus 2 times 6, right? Because it's $3 per burger and $2 per cookie. would that be less than or equal to $20, right? That's what this is asking us. Well, let's see. If I do 9 plus 12, that's $21 I would be spending. Is that less than or equal to 20? No, it is not, right? Wah, wah, that's too much money, right? So no, she would not be able to buy 6 cookies and 3 hamburgers because that would exceed the amount of money that she has to spend, right? So we can kind of put like a little slash through that, right? That's false. Okay, so what combinations would work? Again, there's lots of them, right? So let's see. Let's just kind of run through the gamut here. Can she buy, I don't know, can she buy six burgers? 6 burgers. Again, this is just like that dress question. 6 burgers. Well, if burgers are $3 a piece, that's $18, right? Which would leave her $2 for a cookie. So yeah, she would be able to buy 6 burgers and 1 cookie. And that would be exactly $20, right? Could she buy 5 burgers and 1 cookie? Yeah, she can. In this situation, she can, because this is not an equal sign. So I don't have to equal exactly $20. If she bought 5 burgers, that would be 15. And then plus the 1 cookie, that would be 17. So she would have $3 change. I'm going to kind of write that little note here. She would get $3 in change back from her 20, right? But that doesn't mean it's not a solution, because this is technically a linear inequality, right? So we're talking about graphing, right? And we're talking about a solution region. So she can have any combination of burgers and cookies as long as it's less than or equal to $20. All right, let's see if we can come up with another one. What if she bought 3 burgers? Again, I'm just kind of blurting out a number. 3 burgers, that would be $9. So that would leave her with $11 left. So she would have enough to buy 5 cookies, right? Because that would be $9 plus $10. So that would be $19. So she would be able to have $1 change. And I totally forgot to put the 1. $1 in change, right? This first one was exact, so she would get no change because she spent all $20, right? But a possible combination would be anything as long as it's less than or equal to 20. It doesn't have to be exactly 20 in this case because it's an inequality, okay? Wow, that was a lot. So happy studying. Do your best. I'm sure you're going to do awesome on your test. Let me know if you have any questions.